Hello, this video is for Stat 210 and includes a discussion of the study guide for exam number 3. Okay, let's go ahead and get started then. Exam number 3 is going to cover handouts 9, 10, 11, and 12 is the coverage here. For this semester, quizzes 10 and 11 are going to be also relevant for your exam number 3. All right, let's go ahead and look at the study guide here. The link is there, and obviously the solutions provided at Stats class as well. So let's go ahead and get started. So this first question, just a set of true-false questions from handout number 9. Let's go ahead and get going then. Extreme observations affect the median more than the mean. That's false. So outliers, the mean is more influenced by outliers than the median is. Remember, the median crosses off the smallest and the largest, and then it goes through and ends up in the middle. So outliers are not going to mess up the median, but it will influence the mean. Box plots are used to identify a set of outliers in a data set. That's true. We have box plots and we have z-scores being used to identify outliers. I guess the next one is about z-scores. A z-score above 1 or below -1 would be considered a statistical outlier. That's going to be false. The cutoffs are 2 and -2. So not 1 and -1, but 2 and -2. We definitely talked about this in class. The range is the most widely accepted method of measuring spread in a set of data. That's false. We use the standard deviation. 1e here, the standard deviation is measured on the same scale as the data. That's true. And then the p-value is a probability, so it cannot be less than 0, nor can it be greater than 1. So that is going to be true. This next one here is about alumni who donate money back to their universities. I have 29 different private schools, and I got 21 different public schools from colleges and universities in Minnesota, Wisconsin, and Iowa. So my scope of inference is just on those 3 states there. Multiple choice here. Consider these summaries. The mean and median are larger because they have more observations. That's false. Number of observations do not affect my summary measures. The mean and median are larger, the mean and median are larger for private, means that they're giving more money on average. So that is what the answer is there, is B. So 2B. This one is about standard deviation. The standard deviation for private is larger, thus the percentage of alumni who donate from private institutions have a larger average distance back to the middle. Yeah, that's what standard deviation is measuring. So that is the one that we're going to want there. 4 is a little bit more complicated in that I'm giving you the margin of error. So this is a handout 10 type stuff. Roughly the margin of error. In class we said you could use 2 there, but we actually use some value real close to 2. But here I'm just cutting this, keeping it a little simpler. Just suppose that the margin of error is basically 2 times the standard error of the mean. The standard error of the mean is just the standard deviation divided by the square root of the sample size. So here, when we're looking at this, the margin of error for public is smaller because the number of observations in this group is smaller. That's not going to be true. The sample size actually goes in the bottom, in the denominator of this. Actually, the square root of the sample size goes in the denominator. But if that's smaller, if the sample size is smaller, that's actually going to make my standard error of the mean be bigger. And if I take a bigger number and multiply it by 2, I'm definitely going to get even a bigger number. So the margin of error is actually going to increase in that situation. So A is not right. So that leaves B because C is just both A and B. Now let's talk a little bit about 5. So these are just 95% confidence intervals. Oops, sorry about that. These are 95% confidence intervals. For the private institutions, it's basically between 25 and 35. So again, this is the average amount of percentage. So a little bit there. This is a percent that donate, but then I'm averaging it across the 29 or 21 different schools. So this is like an average percent who donate. So for private, it's going to be anywhere between 25 and 35. And for public, I would expect the average to be between about 13 and 20. So definitely less people are donating back to public institutions than private. These again are the 95% confidence intervals. How about A? These formulas and corresponding intervals allow us to compare the true alumni rate for public and private institutions in any state. Not good, because it's only colleges from Minnesota, Wisconsin, and Iowa, or whatever it was. So A's out. These formulas, corresponding intervals allow us to compare the dollar amount of private and public in these 3 states. But what I'm missing here is that idea that it's for the average percent. Okay, so like in C, I do have that. Average alumni donation rate. These are definitely for the average percent. Now, the reason C is not selected is because that is saying in our sample. So necessary to compare the average alumni donation rate from private schools in our sample to the public schools in our sample. Well, if you want to compare the private to the public, just in our data, for these 29 schools and these 21 schools, you can straight up compare 30 to 16. You don't need these lower and upper 95% means to do that. If you only care about these 29 schools and these 21 schools at the particular time that you collected this data, you can straight up compare 30 to 16. But these lower and upper are going to say, well, I know that this number might change. So maybe I collected this on 2019 or something, and I might be interested in what's happening now in 2023. Then this 30.17 is going to change. Well, it's going to change by this amount, right? That's what the lower and upper are giving me. How much is my average going to vary over repeated sampling? So here, that's going to be between 12 and 20 or so. This mean here, we'll talk about this later in a different question, but this mean is always the middle, exact middle of their 95% confidence interval. Because what we're doing there is we take the mean and we subtract, where is the margin of error? We take the mean and we subtract the margin of error, and then we take the mean and we add the margin of error. So the mean, or my sample mean, the mean from my data, is always going to be exactly in the middle of our confidence intervals. So A, B, and C are out in here, so D is the only one left, obviously, for that multiple choice. Okay, let's pay attention to this one. Is a handout number 10 type problem. I'm computing the difference in crime rates, I guess, between Minnesota and Wisconsin. The differences are computed as Minnesota minus Wisconsin. Just kind of setting up the test, all the different steps. It's a two-sided test here, testing whether or not I have differences. So I'm going to be using prob absolute t here. So definitely 0.0094 is going to be my p-value because I'm just looking for differences here. Testing against 0, testing no difference. My test statistic is, this here is my observed difference. So what is that? Negative 3.06 is where that's sitting. That looks like it's an outlier. Okay, so this negative 2.83 is the test statistic, which is kind of like a z-score. So what do we do with the z-scores? Well, if I'm less than negative 2 or bigger than 2, then I'm an outlier. So negative 2.84 is definitely an outlier. Negative 2.84 is an outlier in our situation. So I do have enough evidence for my research question. So A is going to be my choice there. If you want to look at the p-value, that's 0.0094, which is less than 0.05. So this is kind of all of our standard stuff. I do have enough evidence for my research question. So I do have enough evidence for my research question. So B is going to be the answer there. Again, I'm testing the average difference. So that better be in your conclusions. So if you have to write a conclusion in an open-ended question, make sure and put average in there. Have the p-value attached to the end of each of them. This is testing a difference, so don't be lured into, can I say one is higher than the other one? You can do that with your confidence intervals, but you can't do that here. Remember, they give me a research question, I have to test their research question. I don't get to decide on a different research question. So definitely B is the answer there. This one here is looking actually at the confidence interval, which the confidence interval is basically -1 to -5 or so. Now you might be asking, how can you have a negative homicide rate? Well, we are because we're looking at Minnesota minus Wisconsin. So if that's negative, that means Minnesota's smaller. Right? The only way you're going to get a negative number here is if Minnesota's smaller than Wisconsin. The lower and upper are negative, so that means I definitely have a difference between the two states. Now, because it's negative, I get to say that Minnesota is smaller. All right. So A is going to be the answer there. If this interval was completely positive, then Minnesota would be bigger, right? But I'm looking at the sign here, which is saying Minnesota is smaller. So A is going to be my answer there. Okay, this one is a handout 11 thing, a problem. I'm looking at malignant cells, which are cancerous cells, and then benign cells, which are non-cancerous cells. It looks like I'm looking at some sort of texture measurement on the cell. They have different, I mean, when you have cancer, it does bad things to your cells, and they get morphed, they get blown up usually. So cancerous cells are usually larger than non-cancerous cells. But here we're actually looking at the texture of the cell. I don't know exactly what that means, but we're taking malignant minus benign. So again, if I do something with a confidence interval, then I need to pay attention to how that difference was computed. So here it actually is about 3 to 4 roughly, 3.02 to 4.35. So this interval is all positive. So that means my malignant cells have a larger average texture measurement than my benign cells. So how about A? We're 95% certain that the two difference in the average texture measurement is between 3.02 and 4.36. Yep, right there. This interval provides evidence that there's a statistical difference in the two. Yes, it does, because it doesn't capture 0. You can also see that here, because this is the difference test, whether or not I have differences. So this prob absolute t there, which is less than 0.05. So you can get that there as well. The observed difference is guaranteed to be in our 95%. Yeah. I actually mentioned that up above. This 3.69 is where we start from when we build our lower and upper confidence interval. So the observed difference is 100%. The observed difference in the averages is 100% going to be right in the middle of my confidence interval. That's just because how the confidence intervals are built. Okay, this is about the quality of water in lakes. So this is a lake assessment study. The state of Minnesota definitely has many lakes, and we definitely pay attention to the water quality of these lakes. One of the measures that they use is this trophic index P number. It's just some sort of probably measure of phosphorus or something like that, if it's P, I guess. Here's the summary. In the 1,600 lakes, the average trophic index P is 55.96. The confidence interval goes from 55 to 56. Pretty tight confidence interval, mostly because my sample size is so large here. So my margin of error is really small here. Margin of error is going to be 56.66 minus the 55.96, right? It's just the distance from the upper back to the middle. So my margin of error is really small here. Again, because my sample size is so large. Which of the following is most correct if you want to test whether or not I'm different than 50? Okay, so this is just a little bit of a extension or adjustment to what we did in handout 10. In handout 10, we were almost always testing different than 0, or whether or not I just had a difference. Well, here I want to know whether or not this trophic index P is different than 50. So my confidence interval definitely does not capture 50. The lower side is at 55, 5 units above 50. So I definitely have enough evidence to say that I have a difference. So less than 0.05 because the confidence interval does not include 50. So again, we don't always have to just test 0. We could look at other values, like there we're considering 50. Okay, here I'm testing, what was the question? What's the fastest you've ever driven? Yada, 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 yada. The p-value here is 0.0994 for testing the difference between the two. So I technically don't have a difference between the two in the average amount recorded for the fastest that they've ever driven. So even though I got about 6 mile-an-hour difference here with my sample data, okay, the test statistic and the p-value says that I don't have a statistical difference. So if that's the case, then your confidence interval is going to have to catch 0. Because 0 means they're no different. Take the average female minus average male and you get 0. That means on average they're no different. So because the p-value is not less than 0.05, CI number 3 is going to be the right one. CI number 2 is going to have this. If I'm talking about this one, then my p-value is definitely going to be less than 0.05 because it doesn't catch 0. So I have a difference. And it's positive. It's always positive. So that means that the average female would actually be higher than the average of male. CI number 1, the interval is always negative. Well, if it's always negative, then what? This one is bigger, right? Male has to be bigger than female on average. So if I had a p-value of 0.03, let's say, that's less than 0.05, so I have enough evidence to say there's a difference, then this would be the correct one, provided that males had a larger sample average than females, which they do in this case. So another version of this question is if I were to change this to 0.03, then CI number 1 is going to be your correct answer. Okay, number 10 is just asking whether you want a small p-value or a large p-value. Well, she's hoping to have something be statistically significant, so we want a small p-value less than 0.05. Okay, finally on this one here, we're looking at handout number 12. It's the same pictures that we had in handout number 12. I have different vitamins and looking at differences between males and females. The females are going to be the open circles and dotted lines, it looks like. So again, for vitamin A, right, females are taking in an appropriate amount of vitamin A because that hashed line there, that dotted trend line, is basically riding right on the 0 line. 0 means their actual minus DRI is really close to one another, so they're taking in an appropriate amount. We look at calcium, for example, we're under that target line, so females are not taking in an appropriate amount of calcium. So let's knock these true falses out. Females tended to take in an appropriate amount of vitamin A. Well, that's the one I just described, so that's true. Again, that trend line for females is riding right along that 0 line. That's true. Males seem to be taking in an appropriate amount of iron. That's going to be false because males here in the lower right graph are well above the target. So males are taking in too much iron. So that's false. Females tended to be closer to their DRI for vitamin A compared to males. Again, that one's true because look at how the female line's riding right along their target, whereas male tends to be off. Okay, D and E are a little bit another layer of thinking here. If BMI has no impact, okay, on the intake of the vitamins, then the trend line should be flat. That is going to be true. So if my trend line is flat, so let's look at maybe this one here for vitamin C. We're pretty darn close to target when the BMI is low. We're pretty darn close to target when BMI is high. So BMI really doesn't have an impact. Same thing here for women on vitamin A. Whereas if we look at iron, okay, BMI definitely has an impact because the trend lines don't have 0 slope, or they're not flat. This is definitely tilted down. So that means for low BMI, they're taking in pretty close to target, but for high BMI, they're far off of target. Okay, so there's a big gap here from the target. So for iron, for women anyway, BMI has an impact. The last one is about gender. So if the effect of gender, so how do I look at the effect of gender? The effect of gender is the gap between the two sets of lines. So here, look at the gap for calcium. This is low BMI. Now look at the gap in these two for calcium for high BMI. That gap is pretty much the same. So the effect of gender is the same regardless of one's BMI here. Whereas in iron, okay, that's not the case. The effect of gender is this gap here. That is different when the BMI is low compared to when BMI is high. When BMI is high here, that gap between the two lines is much bigger. So there is a gender effect when I look at iron. There is not a gender effect when I look at calcium. There is a gender effect when I'm looking at vitamin A. Not much of a gender effect when I'm looking at this one here. There's not much BMI effect because the lines are pretty flat. There's not much gender effect because the two lines are pretty close together. All right. How about this last one? Was just the idea of RMSE and also our R squared. So RMSE is just the average amount of error. Okay, so the distance from the points to the trend line. We want the RMSE to be small because it's an error measure. RMSE is actually in the same units as the data. Okay, it's like a standard deviation. R squared is actually a proportion, so that's going to stick between 0 and 100%. It's always a percent or a proportion. So, and it is just the amount of variation that can be explained using our trend line and the predictor variables. So these are really just definition questions, and then can you tell me the difference between those? We talked about this in class, but as RMSE is reduced, then my R squared is going to go up. So yeah, that's just kind of a definition question there to end with, it looks like. So there you go. That is your study guide for exam number 3. Good luck, and we'll see you in class.